So, yeah, hello everyone. Very good evening. So, let's wait for some more minutes so that everyone can able to join this session. So, just everyone joining. So, we will start the class within 5 minutes. So, for as of now, please can you, any one of you can tell me whether am I audible and visible? Okay. So, if I'm not audible or visible, so any one of you can confirm it. Okay, so let's start the session. So, hello everyone. A very good evening to one and all of you. My name is Pooja Verma. I am PMR Research Scholar from IIT Kharagpur, and the instructor for this course is Professor Jayanta Mukhopadhyay, Department of Computer Science and Engineering in the IIT Kharagpur. So this is a live and interactive problem solving session of computer vision. So this is a week two. I hope all of you have gone this week video lecture. So as it TA, here we will solve some problems which will be similar to your assignment question. Okay. So for this week, this is the course content related to this week. This is projective geometry, part 1, part 2, and projective transformation, and then homography and its properties. These are some books and references which you can use while studying. So let's start the problem. Okay, so now it's audible. It's clear or not?
Yes, ma'am. Okay now.
Okay. Okay, so first question is consider a point P is 8, 12 and 4 in the projective space. Convert it into 2D real space. So any guesses or you want to move forward first? Okay, so I'm giving you just some time so that you can at least make some choice for this question. Then I will solve it. So here just recall that here the points are given in the projective space, and now we need to convert it into a 2D real space. Okay, so what will be the possible answer and how we can move forward with this question? Okay, yeah, see. Just a minute, something is going wrong. This time. So, yeah, okay. So the projective point is given as P is 8, 12 and 4. So this is it, the correspondence in the projective space. Okay, now if we want to convert it into the 2D real space, just a minute, everything is going on in the text. I think now it's better. So if we want to convert it in the projective space to the real space, in the 2D real space, so what we need to do in the real space, as we know that the points are given in the form of x, y, right, in the real space. While if we convert it into the projective space, so it will into the form of in the by the third element and with some scalar factor as well, right? So now it is already given in the form of projective space. So what we need to do, just we need to divide this. Let's the x coordinate of the 2D real space is represented by x dash. So what we need to do, we need to divide it with the third component x divided by w. Similarly for the y coordinates also. So y divided by w. So what is the x value? That is 8. W is 4. Similarly here also 12 divided by 4. So here you will get 2 and here you will get 3. So the 2D real space point is 2, 3. So option C is the correct answer for this question. Okay. So this is a 2D real space point 2, 3. Okay, so I hope all of you have understand. So moving to the next question. Now next question is a possible equivalent representation of 2D point 2, 6 in the real after projective projecting onto p square is. So what will be the possible representation of this 2D real point into the projective space? Here we have to convert the real space point to the projective space. Okay. So now what we need to do? So here the real points are given. We need to convert it into the projective space. So the given 2D real point is this is 2, 6. That is corresponds to a real space. Now to convert from real space to a projective space, so already we know that a point x, y in real space, or we can represent it by r square, can be represented into the projective space or projective coordinate by x or y and w, right? So here already 2, 6 is given. So where it is any non-zero scalar, non-zero scalar. Okay, so how we can take it? So let's check by options by going through the options. So by converting back, what will be the projective space point? So first convert 2D point into the real space. So already we know that the converting projective space is represented by x dash y dash. Okay, so if we convert it x by w and y by w. Okay, so here just we will go to the options. So I am taking just a. So if we just divide by a third one, 18 by 4, we what we will get 1 and how much 4.5, right? So this 1 and 4.5 is not equal to the point 2 comma 6, right? That means option A is not a correct option. So we need to discard. Now check by the other options also. The next is given as a 8, 18 and 4. So if we convert it, so x by, so 8 by 4, again 18 by 4. So here you will get 2 comma 4.5, right? This is also not matching with the 2 comma 6. So option B is also not a correct option. Now check with the option C. Option C is 6, 24, and 4. So if we convert it into the project real space, so 6 by 4 and 24 by 4. Okay, so what will be the answer? It will be something 1.5 and 6. It is not also not matching with the real point. Now go with the option D. So D is 8 by 4 and 24 by 4, right? So you will get 2, 6. So option D is only matching with the real point. So option D is the correct answer for this question. Okay, so have you understand how to solve this question? Here already 2D real space point is given. Now we need to find the projective space point. So here already third point is not given. So here we need to go with the options. Okay, to find out the correct option. So have you understand? Can we move to the next question? So moving to the next question. Now next question is, which of the following is a possible set of parallel lines intersecting at the ideal point 2, 5 and 0? So can you try this question at least? Please try for this question and let me know which option will be the correct one. Which of the following is a possible set of parallel lines intersecting at an ideal point 2, 5 and 0? Please answer at least. Then I will solve it. Okay, so already as we know that a 2D line is represented as a homogeneous coordinate vector. I'm writing here a 2D line represented as a homogeneous coordinate vector A, B, and C, and their corresponding line equation will be ax plus by plus c is equal to 0, right? So two parallel lines in a real space intersect at a point at infinity in the projective space. Already as we have seen in the lectures, two projective points or two parallel lines in a real space intersect at an infinity, right? In a projective space. So the point at infinity, that is also called a real ideal point, is the form of x comma y comma 0, right? Which lies on all lines that are parallel and have the same direction in the vector x comma y, same direction vector xy. So here given point is 2 minus 5 comma 0, right? That means we are looking for lines that are parallel and share direction vector, that is 2 minus 5. Okay, so given point is 2 minus 5 comma 0 or 2 minus 5 0. So this line must be share 2 minus 5 and must satisfy the line, here we can say line L, at ABC, where AB must be equal to 2 minus 5. Okay, so any two lines of the form of, so any two lines of the form of, just not everyone joining right now. So any two lines of the form of 2x minus 5y plus c is equal to 0, where c is different, where c can be a different, and parallel, so they intersect at lines ideal at 2 minus 5 0, right? So already we know that the direction, okay, right? Directive vector 2 minus 5, and we can have different c values. We can have different c values. So which options, different values? So which options can be correct? So that they intersect, their direction vector will be the 2 minus 5 only. 2 minus 5, and c can have a different values. So which options can be a correct answer? Which have 2 minus 5 and different values of c. So option B only matching 2 minus 5 1, c here c values 1 and 9. So they will intersect at the ideal point. Okay, so option B is the correct answer for this question. So yeah, have you understand this question, or you need to repeat it again? You want to repeat this question? So already we know that the corresponding line equation is represented by ax plus by plus c in a homogeneous plane, right? Homogeneous coordinate. So two parallel lines in the real space intersect at a point in infinity, as we know that, and the point at the infinity can be a form of x comma y comma 0 or x comma y comma c. If they are at infinity, then x comma y comma 0, and they can have a scalar multiple of, already we have seen. So the line that we can represent a comma b comma c, and where a comma b is the direction vector. So already we know that here a comma b, that direction vector is 2 minus 5, and for any two lines in the form of this equation, homogeneous equation, can be represented by 2x minus 5y plus c, and c can have a different values, okay, for a parallel line. So that's why direction vector is this, and c can have a different values. So just we have to match 2 minus 5, and c values can have a different values. Okay, so that's why option C is the correct answer for this question. Okay, so I hope all of you have understand. So now, can we move to the next question? Okay, so now moving to the next question. Next question is, consider a projective transformation a transformation matrix is given and the conic matrix conic C is also given. Find out the transformation of a conic C under H. So now we have to find out the transformation of a conic C under H. So how we can move for this question? So to find out the transformation of a conic C under H, so I'm just writing out that formula. Transformed conic, that we called a transformed conic, and conic. So here transformed conic we can represent by C dash. Okay. So it is find out by H of minus transpose C, H of inverse. That is the inverse of H, inverse of projective transformation, that is H. Okay, this is the inverse transpose of H, and this is the conic matrix already here given here. So transformation matrix and the conic matrix both are given. Now we need to put in that formula and then we need to solve it. Okay, so first we need to find out the H inverse of H. So how we can calculate the inverse H? Any one of you? How we can find out the inverse H? Any one of you? This is a big
Adjoint of
yes, yes,
adjoint of H divided by determinant
yeah,
of
correct.
H.
So yeah, please solve it with me. So any one of you can let me know what will be the determinant of H. To find out, I'm just writing step by step. To find out P H inverse, we need to find out one by determinant of H and
Minus 2,
adjoint.
I think.
Yeah, yeah, correct. Minus 2. So how we can find out the determinant of H? First, we need to find out determinant of H, then adjoint of H. Now, next, how we can calculate the adjoint of H? Any one of you? So, projective transformation matrix is given. So, just take first this one and just cross multiplication of these two, right? So, 1, 0 minus 1, then minus 1, then just take it 1 minus 0, right? 1 minus 0, then plus 0. Here it is a 0, so whole will be the 0 only. So 1 minus 0, so if you solve it, so here you will get minus 1. Here it is also minus 1. Here you will get 0. So determinant of H value is minus 2. Okay, similarly, we have to calculate adjoint of H. So adjoint of H basically inverse of the cofactor. Inverse of cofactor of this matrix X. So first that is called Cij. Okay, cofactor is called Cij. So first like C first row first column. So first we need to calculate C11, C12, C13, 212. So all we need to first determine. So anyone of you can you calculate it first? Then take a inverse of that. Oh sorry, transpose of that, not an inverse. It is already we are calculating the transpose of cofactor H. So first find out all the cofactors of H, then transpose it. Okay, just taking the another slide to solve it. So if you find out the all the cofactors and taking the transpose, so A the adjoint of H, and directly already I have solved it. So I recommend you to solve it first. Then okay, so I'm just taking 1 minute of time. So anyone of you can tell me what will be the adjoint of H values in the matrix? Then I will write here. Okay. So just first try. Please find out the all cofactors.
Yes, ma'am. 1 minus 1, 1.
Okay, yeah.
Minus 1, 1, 1. Next row. And then
Okay,
third
you
row,
are
1 minus 1.
okay. So what I have got the cofactors. Already you are telling the adjoint directly or cofactors. So okay, I directly calculated all the cofactor and I'm writing just adjoint of h that I have got minus 1, minus 1, 1. Here also minus 1, 1, minus 1, 1, minus 1 and minus 1. So is it correct? Have you got same? So now if you calculate h inverse, you will get minus 1 by 2 already because determinant is minus 2, right? Minus 1, minus 1, 1, minus 1, 1, minus 1, 1, minus 1, and 1. Okay. Further, you just multiply this minus 1 by 2 in the inside, you will get 1 by 2, 1 by 2, minus 1 by 2. Here again, 1 by 2, minus 1 by 2, 1 by 2. Here minus 1 by 2, 1 by 2, and 1 by 2. Okay. Now we have to also find the inverse transpose of h. Okay, so for getting h of minus p, what we need to do, just take again h inverse of transpose of this values. So you will get the 1 by 2, 1 by 2 and minus 1 by 2. Again 1 by 2, minus 1 by 2. Here it is 1 by 2. Okay, it is all 1 by 2, 1 by 2, okay, minus 1 by 2, and it is also 1 by 2, minus 1 by 2, 1 by 2, and here it is also 1 by 2. Okay. Okay, so now we have find out the H inverse and H of minus transpose. So to find out all the transformed conic, so already we know that formula is H of minus transpose of H C into H inverse. Okay, so now if you multiply these two, these three matrix, what you will get? So here 1 by 2, 1 by 2, minus 1 by 2, again 1 by 2, minus 1 by 2, 1 by 2, minus 1 by 2, 1 by 2, and 1 by 2. And the C value is 2, 1, 1. It is already given in the equation, right? 1, 2, and 1. Now again, you have to multiply with the H inverse, which we have find out. 1 by 2, 1 by 2, minus 1 by 2, 1 by 2, minus 1 by 2, 1 by 2, minus 1 by 2, 1 by 2, and 1 by 2. So any one of you, can you calculate and let me know which will be the correct answer for this question? First multiply these two matrix, then multiply with this matrix. Any one of you? Please try at least. It is a simple matrix multiplication. It is a formula for finding out the transformed conic matrix. So I will write it here. Answer. So any one of you, are you solving these questions?
Solving, ma'am.
Okay, okay. So I will wait for some time, then I will write. You can manage these answers.
You can give the answer, ma'am. Later we can check.
Okay. So I will write it here. So final answer you will get 0, 1, 0, 1, 0, 0, and 0, 0, 1. Okay, this is the answer for the transformed conic. Now let's check which options can be a correct one. So 0, 1, 0, 1, 0, 0, 0, 0, 1. So here option B is the correct answer for this question. So have you understand this question? All of you? To find out the transformed of the conic under H, that is projective transformation. So I hope all of you have understand. So you can solve it later because it is a little bit lengthy. Okay, so moving to the next question. Now next question is identify the point lying on the conic C. Which point is lying on this conic matrix C? So any one of you have any idea how to proceed with this question? So already the conic matrix is given. Okay, so conic matrix C is given. So to find out the point lying on the conic, so let's say a point P is x, y, z is lying on the conic, but here it is like x, y, z transpose because here it is written in the row form. So you can write it in x, y, z. Okay, lies on the conic, like lies on the conic C if and only if P transpose C P is equal to 0. That means that point, transpose of that point, then multiplication of that conic and this P that not in transpose form, is equal to 0. Okay, so if this calculation is equal to 0, that means that point lies on the conic C. Okay, so how we can solve this question? So here we don't have any option, so we have to go by options. Okay, so first take option A and solve it and check whether it is lying on the conic or not. If it is giving this multiplication will give 0, then that means it is lying on the conic. If it is not, then that means it is not lying on the conic. So first I am just calculating by option A and then I will wait for 2 minutes. You need to solve this question and then let me know which are the options are the correct one. Okay, so just I am doing with one so that you can able to do that. Okay, so let's say I am taking this point P is equal to 1, 0 and minus 1, right? So what is the formula? P transpose C P. Okay, so P transpose that means 1, 0, minus 1. Here I am taking. So any ways you can take anyone. 1 minus 1, 1, then minus 1, 1, minus 1, 1, minus 1, and 1. Then next one is P. Okay, so 1, 0, minus 1. That must be equal to a 0. Okay, so now can you multiply this please and let me know what will be the answer? 1, 0, minus 1. So first we need to multiply these two. Okay, so what will be the answer? So just multiply first row in this column, then next row, this column, next row, this column. So 1, 1 into 1, 1, minus 1, 0 will be the 0 only. 1 into minus 1. So minus 1. Okay. Now similarly next one, minus 1 plus 0 plus 1. Right. Now next one is 1, 1 into 1, 1 minus 0, 1 into 0, and then 1 minus 1, then will be the minus 1. So here you will get here 1, 0, minus 1, and this matrix will be the 0 only because 1 minus 1 will be cancelled out, 1 minus 1, 1 is cancelled out, 1 minus 1. So 0, 0, 0. So if this will multiply by this column, that will give a 0 only, right? So that means this holds a correct P transpose C. P transpose is equal to 0. That means option A. That means option point P 1, 0, minus 1 lying on the conic. Okay. Option A is the correct. Now check with the others also. Option B, C and D. And let me know whether it is lying on the conic or not. Any of them. Because in the exam, there will be a multiple choice question as well as multiple corrections will be there.
Ma'am, can I proceed by multiplying P transpose C and then P?
It is better if you just multiply with first this two, then any
Oh,
of way you can do that. But it will be
okay.
the lengthy in that case because you need to multiply this row, this column, this row, then just multiply. You have all the possibilities.
Okay, ma'am. Thank
So just please solve everyone. Please solve with the other options also. I have solved with option A. Can you check with the other options also? Then I will just go through that. I will solve all the possible ways. Then we will able to find out which options can be a correct one. Please solve. Okay, so I'm moving with the next options. You also solve parallelly, then we can discuss on it. Which options are the correct one? Okay, so I'm just going to the next option. That is option B. The point P is given as -1, 0, -1. Right? Now, -1, 0, -1. Okay. So now we need to find out P transpose C. P must be equal to 0. In that case, the point lies on that conic. Okay, so P here is -1, 0, -1. The conic matrix is given as 1, -1, 1, -1, 1, -1, 1, -1, and 1. Again, that is a transpose. So 1, -1, 0, -1. Okay. So now next
It's
is
4.
yes, anything. Okay, so just multiply this row, this column, this row, this column. So -1, -0, then again -1, right? So next one is a +1, -1, -1. Then 1 into 0, 0. -1 into -1 will be the +1 again. Here -1, 1 into -1, then -0, then 1 into -1, -1. Okay. Now what we will get here? -2, 2 and -2. Again that will be multiplied by this. Okay. So here what do you will get? -1 into -2. So 2,
4,
right?
it is non-zero.
Yeah. Okay. And plus 0 here plus 2. So here you will get 4. So it is a non-zero. That means option B is not a incorrect. Or you can say that point -1, 0, -1 does not lie on conic. On conic. Now next, can you solve for option C? So point is given as -1, -1 and 0. So point for C -1, -1 and 0. Solve similarly -1, -1 and 0. Now next, that is 1, -1, 1, -1, 1, -1, 1, -1 and 1. Now -1, -1 and 0. Now just multiply with this 2. So -1 plus 1 plus 0, right? Plus 1 minus 1 minus 0 minus 1 plus 1 plus 0. So here again you will get all 0, right? So if you multiply with this, you will get only 0. So that means point P minus 1 and 0 is also lying on the conic is equal to 0. That means this point is also lying on the conic. On conic. Okay, so option A and C is lying on the conic. Now we need to solve with the other also. So just I'm removing it from here so that we can calculate. So for the option D as well. Okay, so last point, option D is 0, -1, -1. That is, so can you solve and let me know whether this point is lying on the conic or not? The point is 0, -1, -1. 0, -1 and -1, right? So just calculate it. 0, -1, -1. The conic matrix is 1, -1, 1, -1, 1 and -1, 1, -1, 1. And next point is 0, -1 and -1. 0, -1 and -1. That will be the, so first one is 0, then next minus, sorry, +1, -1 into -1. Now next one is -1. Similarly for 0, -1 plus 1, 0 plus 1 and -1.
Minus
And
2 non-zero.
which one? It is. How? So here
Yes, no
all
answer
will,
-2 correct. No?
no, no, here also you will get a 0. See, just check 0, -1 is the point. So if you
Ah,
multiply
yes, ma'am.
0, here +1, then -1, it will be the cancel out. Similarly for the next, so here you will get all 0, right? So if you multiply with this, you will get 0 only, right? So that means this point is also lie on the conic. Okay, so option D is also lying on the conic. That means 0, -1, -1. So have you understand how it has come? Have you got this question? I mean option D. Are you getting, you are
Yes.
getting to, right? So now have you got this correct answer? So now option A, C and D. That means these 3 points lying on this conic matrix C. So here the multiple options are correct. So please, I would like to suggest if this type of questions are given, so if you are getting in the first point the correct answer, please go through with all these options also. There will be the multiple correct options also there. Okay. So just don't stop with the first option. Just check with the other options also. Okay. Otherwise, you will be marked the wrong answer as well. Okay. So now I hope you have understand this question. Now moving to the next question. Now next question is consider following two lines, that is L1, 2, 3 and 4, and for L2 8, 12 and 16. Select options. Here options here they have written about the underlying property about the two lines. Option A, two lines are parallel. Option B, lines are intersecting. Option C, two lines represent the same line in the projective space. Or option D is none of the above. So any one of you want to answer this question? That two lines underline which property? two lines are parallel or intersecting, or two lines represent the same line in the projective space. Which options are the correct one? Here two lines are given in the projective space, right? It is not a real space because the third component is also given. That means it is a projective space point. Okay, so these are the represented in the homogeneous coordinates where a line in 2D projective space is given by the equation. Already we know that ax plus by plus c is equal to 0 and line L is A, B and C, right? While in the projective geometry, two vectors represent the same line or point or plane if they are scalar multiple of each other. That means L2 is equal to lambda L1, where lambda is the some non-zero scalar, some non-zero scalar, right? So here point L1 is given as 2, 3 and 4 and L2 is given as 8, 12 and 16. So is there anything common in any of these lines? So if we take here 4 common, we will get 2, 3 and 4, right? That means L2 can be represented by 4 L1, right? Where 4 we can relate with the lambda, right? Right? That means that came in this form, this L2. So that means they are a scalar multiples, right? So the two lines represent the same line in the projective space. They are not a distinct line. So they are neither intersecting nor just parallel. They are identical. These two lines are the identical because they are relating with the same point with some scaling factor. Okay. So that means we can just correct this answer. Two lines represent the same line in the projective space. That means these two lines represent the same line in the projective space by some scaling factor. Okay, so have you understand this question? So have you understand? Can we move to the next question?
Yes, ma'am.
Okay,
Two lines are parallel. That also true, I think.
that can be. That can be.
Lines intersecting cross product to be zero.
Lines, if they are intersecting, no. If they are in the infinite, in that case, if it is zero, that means that are in the infinite value.
Oh, okay.
Yeah, they will intersect at a point, any one point. Okay, so can we move to the next question?
Yes, ma'am.
Okay, so moving to the next question. The next question is note line at infinity containing all ideal points in a given by L infinite value is given 0, 0, 1. Consider a transformation H. The H transformation matrix is given. Compute the vanishing line in the transformed space. Now we need to compute the vanishing line into the transformed space. So how we can calculate it? So here the given line at infinity and the transformation matrix H. So we need to find out the transformed vanishing line. So in the projective geometry, the transformed vanishing line is calculated by, that means that is represented by, like it's represented by L dash, that is equal to h of minus transpose L infinite. Okay, so this is calculated by a h of minus transpose L infinite. Now to calculate of h of minus transpose, first we need to calculate h of inverse. Okay, and already we have calculated h of inverse. The formula is 1 by determinant of h into adjoint of h. So please all first calculate the h inverse, then first at least calculate the determinant of h, then adjoint I will calculate it because it's lengthy process. 3 cross 3 matrix it is, so you can calculate it later. I will write it here. So just take a 2 minutes. Please calculate determinant at least. Any one of you can you calculate? Okay, so determinant of h would be 2, right? First we are taking 2, this one. Then 3 minus 2, right? 3 minus 2, then minus 3, take this one out, and then cross multiply of these two. So minus 4 and minus 6. Then again take it out, minus 4, and calculate with these two. So minus 4 minus 9. So 2, 3 minus 2 is 1, minus 3, here minus 10 it is,
20.
then minus 4, yes, it is minus 13. So you will get 2 plus 30 plus 52. If you just add all those things, so you will get 84, right? So the determinant of h is 84. Now we have to calculate. To calculate for adjointed, first we need to calculate.
Correct, ma'am.
Yeah, we need to calculate transpose of cofactors of h. So I'm writing first cofactors of h, that you can represent Cij also. So you will get here 1, 10, minus 13, minus 7, 14, 7, 18, 12, and 18. These are the cofactors. Now, to find out the adjoint of h, just take the transpose of that. So what you will get? What will be the transpose? 1, 10, minus 13, right? Just take row into column, column into row. So minus 7, 14, 7, 18, 12, 18, right? So this is a adjoint of h. So just let me add one more. Okay, so we have calculated adjoint of h. Now we need to calculate h inverse. So for h inverse, so 1 by determinant, that is 84, and adjoint of h. So 1 minus 7, 18, 10, 14, 12, minus 13, 7, 18, right? So Any one of you, can you calculate it? Just multiply, sorry, divide with this 84 and let me know what will be the answers. Just it is a division inside this matrix. 1 divided by 84 minus 7 divided by 84, 18 by divided by 84. Please let me know the values at least. Okay, so just you can calculate. I'm also writing 0.012, 1 divided by 84, then minus 7 divided by 84, you will get minus 0.0833. Now next you will get 18 by 84, 0.214. Similarly for 10 by 84, you will get 0.12. Here you will get minus 0.15. Here you will get 0.166 and it is 7. So again 0.0833. Here you will get 12 by 84 is 0.143. Here you will get 0.214. Right? But we have got the H inverse, but we need to find out H inverse of transpose. That means H of minus transpose. So just find out, just change the row into column, column into row. So 0.012 minus 0.0833, 0.214, 0.12, 0.166, 0.143. Now minus 0.15, 0.0833, 0.214. Right? Now we have got H of minus transpose. Now what we need to do to find out the transform vanishing point L dash. So H of minus transpose into L infinite. So just we need to multiply with this and L infinite point. So it is already given. So it is given 0, 0, 1. Right? So just multiply each row with this column. You will get what you will get. So 0 into 0, 0 into 0, sorry, 0.012 into 0, 0.12 into 0, and here minus 0.15 into 1. So first is 0 point minus 0.15. Now similarly, all those factors will be 0. So here you will get 0.083, 0.214, or you can say 0.833. So transform vanishing point you will get minus 0.15, 0.0833, 0.214. Okay, so let's check which options are matching with this one. So points what we have got minus 0.15, 0.0833 and 0.214. So best matching option is option D, right? Option D is the correct answer for this question. So have you understand this question? How to solve? Just putting a simple formula and solving it. Okay. Just master yourself to finding out the H inverse. Okay. So, okay. Moving to the next question. Now, now next question is consider the direct linear transform algorithm for a point correspondence to xi dash to xi, which involves the following equation, which homogeneous coordinate using the homogeneous coordinate representation of points xi prime and xi in the transformed and original 2D projective space where H is a projective transformation, and this is given in x prime equivalent to H of x. Choose the correct option from the following. So which option is the correct one? Option A, vector x prime and hx may have similar magnitude but different direction. Option B, vectors x prime and hx may not equal. They have similar direction but different magnitude. Option C is vectors x prime and hx may be equal. They have similar direction and magnitude. And option D is none of above. So which option is the correct one? Okay, so here detailed answer is given. So I am just explaining this one. Okay, so to determine the relation between the transform point x prime and the product of the transformation matrix H and the original point x in the homogeneous coordinate, and already it is given x prime equivalent to h of x, where h already we know that projective transformation matrix. Okay, it is here already given projective transformation matrix. H is a projective transformation matrix. So in the projective geometry, homogeneous coordinates are defined up to non-zero scale factor, and x may be equivalent to y, means that x and y are equivalent up to a non-zero scalar multiple. So they are equivalent up to a non-zero scalar multiple. Okay, that means, so the notation x prime equivalent to h of x are proportional. They differ only by a non-zero scale factor lambda, that is already we know that x prime is equal to, that means h of x, right? Since x prime and hx are the scalar multiple of each other, they must have same direction, and their magnitude, however, can be a different due to scalar factor lambda. Okay, so that means option vector x prime and hx may not equal. They have similar direction but different magnitude due to this scalar multiple factor. Okay, so for this question, the option B is the correct one. Okay, so have you understand this question? Okay, so I hope you have understand this question. So now moving to the next question. So here detailed explanation is given. You can see it later. Already I have explained. So you can also check in the later part. So now moving to the next question. Now next question is recollect direct linear transform algorithm for non-homogeneous equation AH is equal to 0. The matrix A is formed from the following equations relating a point xi and its transformed point xi prime in the 2D projective space. So here it is given where xi prime is equal to xi prime, yi prime and wi prime transpose, and xi is equal to x same xi, yi and wi transpose, where I varies from 1 to n. Now choose the correct option about the dimension and rank of the involved matrix for solving AH is equal to 0 using reality for a set of non-homogeneous equation. Okay, so now how we can solve it? Okay. So first I will explain it here. You can see the detailed answer in the later part. Okay, already a detailed explanation of this question is given. So just here it is given DLT algorithm solve the non-homogeneous equation by AH is equal to 0, right? Where a matrix A is formed equation relating a two point X, that is X, Y and W, and its transformed point, that is Xi equal to Xi, yi, and wi, right? Just- Okay, so there are n such points already. It is given because that I is very 1 to n. So there are n such points. So each 2D point corresponds to provide two independent linear equations for the element H, and the homography matrix H has 9 elements because it is a 3 cross 3 matrix, right? It is a 3 cross 3 matrix already given. Okay, but since it's defined up to a scale and it has a 8 degree of freedom. Okay, so first we need to determine the dimension of H. So here vector H represents the element of the 3 cross 3 homogeneous or homography matrix H, right? So it has a 3 cross 3, total 9 elements. Now H is a column vector and it has a dimension 9 into 1. Okay, this one. Now to determine the dimension of A, so each point corresponds to x and xi, right? This one provides two independent linear equation, two independent linear equations. Already it is defined. For n point correspondence, there are two n equations will be there, right? For n point, there will be two n equations will be there. So the matrix A has two n rows will be there, two n rows will be there, right? So since AH is equal to 0 and H has a 9 cross 1 and A must have a 9 column. So therefore the dimension of A would be 2n into 9, right? But here we can define not exactly 9 because there are total, how many variables will be there total? So now next, first we will determine the rank. So for unique solution, that means up to a scale for H, a rank A must be 8. For any rank n minus 1 ranks will be there, right? So here total n is 9. So 9 minus 1 total rank will be the 8 only. And this requires at least 4 points correspondence. That will be at least because two n equations will be there, right? So at least 4 point correspondence. That means 4 point correspondence will be there. So 2 into 4 will be the 8 only. So which options will be the correct one? So here total 3 cross 3 elements are there, but to define the rank, n minus 1 will be there. So total, the rank is 8. Okay, so dimension, we can scale that dimension. Okay, so the answer for this question is option A, I think, yeah. So option A is the correct answer. 2n into 8 equations will be there. It will come because we can scale up to 8 and dimension of A that H will also scale up to 8 and the rank we have got 8 only. So option A is the correct answer for this question. Okay. So have you understand this question? Okay, have you understand? Can we move to the next
Ma'am,
question?
why n minus 1 to be considered for non-home? Is it for non-homogeneous equation?
How you are defining the rank of that any matrix? In general, we are getting n minus 1 if there is a n rows or n columns. So
Okay.
that's why n minus 1. And that's why for unique solution, we have to scale it up to 8 only. The 9 is the maximum one. So to find out the unique solution, we can scale up to 8. Okay, that's why here it is now next coming to n into 8,
Okay, ma'am. Thanks.
not 9. Okay, because otherwise it will go beyond that point. Okay, okay. So now moving to the next question. I hope you have understand this question. Okay, so here the detailed solution is there. So you can check it in the later part. So now moving to the next question. Now next question is consider the following homography matrix H between two images I1 and I1 to I2 of the same scene. H homography matrix is given. Suppose an image point in I1 given by the point is given in the real space 5, 6. Find out the corresponding point in I2. What will be the corresponding point image in I2? I1 is given. We need to find out the image point in I2. Okay. So given homography matrix is given. Image point in I1 is given. In I1 is given 5, 6 into a real space. Okay. So in the homogeneous coordinate, in the projective space, what will be the value in homogeneous coordinate? So that point x will be scaled 5, 6, 1, right? In the homogeneous coordinate, to compute a transformed point, transformed point that we can say x prime or x dash, that is equal to h of x, or where x is the point in I1 that belongs to a real space. Okay, x. In the first we need to convert it into the homogeneous space by adding 1. Okay, so now just calculated transformation matrix is given, that is 1, 3, 5, 4, 3, 7, 5 minus 4, 2 are corresponding homogeneous coordinate of image I1, that is 5, 6, 1. So can you calculate it and let me know what will be the value of this matrix by multiplying? So first row in this column, now next row by this column to the next. So 1 into 5, 5 plus 5, 3 into 6, 18 plus 5 into 1, 5 again, right? So 4 into 5, 20 plus 3 into 6, 18 plus 7. Now next 25 minus 24 plus 2, right? Now the final, if you just calculate it, you will get 28, 45 and 3, right? This is a transformed point, okay, in the projective space. Now we need to convert it into the into back or 2D point. into the real space. So how we can convert it? So already x dash we have got 28, 45 and 3. Now convert back into the real space. So what we are doing just, so x divided by w and y divided by w, right? It is a, let's say x, it is a y, it is a w. So what you will get? 28 divided by 3 and 45 divided by 3. Okay, right? Now I'm writing it here. So you will get, how much you will get? So 28 can't be divided by 3, or you can write it in that decimal form, but already it is here. Now next, it is a 15. So this belongs to a corresponding point in I2. That will belong to the corresponding point in I2. Okay. So which option is correct one? Option A is the correct answer for this question. So have you understand this question? So a point in I1 is given. Now we need to find out the corresponding point in I2. Okay, in the same thing. So already homography matrix is given. So first what we need to do, that real point must be projected into the projective space. For that, here we need to simply add 1 in the to make a homogeneous coordination, and then compute h into x to compute a transformed point. Okay, using this formula. Just multiply it, you will get the transformed point, and again convert back into the real space. Okay, so you will get that corresponds to the point in I2. Okay, okay. So I hope you have understand this question. Now we are moving to the next question. Okay, so now next question is the equation obtained by transforming x square plus y square minus 6x plus 10y minus 2 is equal to 0 to the parallel axis through 3 minus 5 is. What will be the parallel axis through 3 minus 5? So how we can calculate it? So here what we need to do, we need the equation that is obtained by transforming this equation to the parallel axis through point 3 minus 5. Okay, so what we do, so let's the coordinate of x, y of any point on the given curve. This is curve is x square plus y square minus 6x plus 10y minus 2 is equal to 0. Change, change to x comma y, capital X comma capital Y. Okay. On the shifting the origin to the point, on the shifting origin to the point 3 comma minus 5. So the new axis remaining to the parallel to the original axis, then that new axis that we will get, that is parallel to the origin axis. Then how we get, so the new transform point will be capital X must be equal to x plus 3, and that new transformed y axis will be the y minus 5, right? Now put the values of x and y in these equations. Okay, just put here it is x, here it is capital Y. Sorry, it is a small. It should be small, here it will be the capital. Okay, so now put this x and y values in this equation, then find out the transformed point. So x square, that means x plus 3 square plus y minus 5 square minus 6 x plus 3 plus 10 y minus 5 minus 2 is equal to 0. Just solve it, we will get x square plus 9 plus 6x, right? Just open it. A square plus a square plus 2ab. Similarly, for this one, y square plus 25 minus 10y minus 6x minus 18 plus 10y minus 50 minus 2. Okay, let's check. Anything is cancelling out. 6x minus 6x plus 10y minus 10y will be cancelled out. So here you will get x square plus y square, just plus 9 plus 25 minus 18 minus 50 minus 2. If you add all those things, you will get, and minus 36 is equal to 0. So finally, x square, if you rewrite it, plus y square is equal to 36. So this line will be parallel to the axis 3 minus 5. So correct answer is option 5, x square plus y square is equal to 36. Okay. So I hope you are understanding. So now moving to the next question. Okay. So next question is, explain the geometric meaning of the homography matrix H in 2D projective space. So what is the geometric meaning of a homography matrix H in 2D projective space? Any one of you want to explain this one? Please answer at least. Okay, so what is the geometric meaning of a homography matrix H in the 2D projective space? So answer for this question is, a homography matrix H that is belongs to a real space defined a projective transformation between two planes. For example, two images of the same scene take from the different viewpoints. We can take from the different, it maps points in a one image to another by the equation x prime that may be tilted equal to the h of x, where x belongs to the projective space is a point in the first image and x prime would be the projective is the corresponding point in the second image, and the symbol indicate equality up to the scale. That means homogeneous coordinate up to that will be the equal up to the scale. So that is a homography matrix H that defines a projective transformation between two planes that can be taken from the two different viewpoints. It maps in one image to another by this equation. Okay, that is x prime that is equal to h of x. That can be equal up to a scale. Okay. Now next question is, why do we use homogeneous coordinate for representing points and transformation in projective geometry? Why do we use homogeneous coordinates for representing points and transformations in projective space? Why we require this one? Okay, so here the homogeneous coordinates allow representation of points at infinity, that means ideal points that are the ideal points, or all linear transformation including translation and projective transformation as a matrix multiplications, and that is undefined mathematical treatment of affine perspective and projective transformation and easy representation of vanishing points and lines. That's why we require homogeneous representation of the coordinate that will allow. Okay. So this is the answer for this question. Okay. So now next question is in the direct linear transform algorithm, that is called DLT also, to solve the equation AH is equal to 0 where H is the vectorized form of the homogeneous matrix, what is the minimum number of points correspondence required? So what will be the minimum number of points correspondence required? Already we have explained in one place here that question. So already we know that each point correspondence contributes two equations, right? Each point correspondence required two equations, and since H has 8 unknowns excluding scale, at least 4 correspondents are required for unique solution, right? So in the previous question, we had seen that H has 8 unknowns excluding scales. So for that, to make a 2n equations, that means because each point correspond to two equations, so for that, at least if you do that to make 8 it at least 4 correspondence required. So option C is the correct answer for this question. Okay. Okay. So I hope you are getting. So moving to the next question. Now next question is two parallel lines in an image are represented as L1 235 and L2 23 minus 4. What is their vanishing point? So what will be their vanishing point? So any one of you have any clue how to solve this question? Anyone? Can you suggest for this question how to solve? Okay, so here it is given two parallel lines in an image are represented. That means these two parallel lines are given. So L1, 2, 3, 5.
I transpose plus Ji transpose, no? Is it right?
Uh, Ij transpose. Okay, just it is a multiplication of these two and mean that is intersection of two lines. Yeah, you are I think correct direction. You are so
Okay.
that is correct. Your I, J, and K, and then just write these two points and calculate that one point. 2, 3, and minus 4. Here two points are given. Vanishing point means the intersection of two lines. So we can this cross product of these two lines. So you will get the another one. So how we can find out the cross product of these two lines? That is from this one. IJK. So first line 2, 3, 5, and now next line is 2, 3, and minus 4. So how we can solve this cross product of these two lines? Then you will get the vanishing point. So can you solve and let me know the answer? What will be the answer for this one? So I just written that matrix. Just you have to multiply it. So any one of you want to answer this question? So any one of you are solving? Okay, so just
Minus
solve.
27, 18.
Okay, yes, minus 27 I plus 18j plus 0k. Yeah, minus 27 and 18. Correct.
Mm.
So I, so if we are
Sorry,
taking
sorry.
I, yeah.
Mm.
So 3 into minus 4, this one, then minus this one, right? Minus 12, minus 15, then minus j. If you take this j common, this line, this line, then just make a multiplication with these two. So minus 8, minus 10, right? Then plus k, just take this, go in this column out, we will get 6 minus 6, right? So here you will get minus 27I plus, here it is a minus 18, so minus minus will be the plus 18j plus 0k, right? So this is the vanishing point, and that can be also represented by minus 27, 18, and 0, right? Now you can, here something is common, uh, so just make D homogenize, D homogenize it. That means remove the scaling factor, scaling factor. So what will be the scaling factor here? Right, 9, right? So 3, 2, and 0, right? So just remove this one. So that's correct, removing scaling. So correct vanishing point you will get minus 3, 2, 0. So this is a vanishing point for this two parallel line representation. Okay, so minus 3 to 0 is the vanishing point. So have you understand what is the, if there are two parallel lines are given, how you solve for the vanishing point? So yeah, have you noted down? Can I move to the next question? So have you understand this question? Please answer at least. Have you understand this question? If two parallel lines are given,
Yes,
how to
ma'am.
solve for vanishing point? Okay. Okay. So moving to the next question. Now next question is, given homography matrix H is given and the image and a point in image I1 X is given. Now find out the corresponding point in image 2. It is a previously question, a similar type of question we have solved. So can you solve this question? The homography matrix H is given, a point in image I1 X, that is X is given. Now the corresponding point in image I2 we need to find out. Okay, so first we need to convert this real point into the homogeneous form, right? That is X you will get in the projective homogeneous form 2, 1, 1, right? Or to compute the transform point, we know that already to compute the transformed point, that is X dash is equal to H into X. So just multiply H into X. What you will get? X prime. So just multiply this H by this X. You will get. So just this row to this column. So 4, right? Then 0 into 1 plus 0. 1 into 1 is 1. Now next. So 2 plus 2 plus 3. right? Sorry, 1. 1 into 2, 2. 1, 3. Yeah, correct. Now next, 0 plus 1 plus 1. So x prime you will get 5, 7, 2, right? That is a transformed point. Okay. Now we have got the transform point. Now again we have to convert back into 2D space. Convert back in 2D space this point. So what we need to do, just 5 divided by 2 and 7 divided by 2, right? So here you will get 2.5 comma 3.5, and this point corresponds to image point in I2, right? Image point in I2. This point is correspond to image point I2, right? Okay. So have you understand this question? Now, based on that, the 17 question is also based on that. So, given the same H, the same homography matrix is given as above, and point x prime we have got 2.5 and 3.5. Find the original point x in I1. Again, we have to again find out the original point x using the inverse homography matrix. Okay, so again h is given, we need to find out the inverse of h. So how we can find out the inverse? H inverse 1 divided by determinant of h and adjoint of h. So what will be the determinant of h? Can you calculate? So 2 into 2 minus 3 minus 0 something 1 minus 0 plus 1. So 1 minus 0. So here you will get minus 2 plus 1, you will get minus 1. So the determinant of h you will get minus 1. Okay. Now we need to calculate cofactor. So I am just removing it, all those things from here so that I can calculate it. So determinant of that h we have got. Now we need to find out adjoint of h. So first what we need to do, find out all the cofactors of that and then take a transpose of that cofactor. You will get a adjoint of that h. So already I have done, I'm directly writing the adjoint of h here. So you will get minus 1, 1, minus 2, minus 1, 2, minus 5, 1, minus 2, 4. Okay, this is it. Now calculate h inverse. Already we know that 1 divided by minus 1 and multiplied by this adjoint. So I am just directly writing because just we need to multiply by the minus sign in this. So you will get 1 minus 1 2, 1 minus 2 5, minus 1 2 minus 4. So here you will get a h inverse. Now what we need to do similarly to find out the original point x, what we need to do, just h inverse into that x prime. Find out the original point. H inverse into x prime. Okay. So convert it into the homogeneous form first. X prime already we know that it is in the form of 2.5, 3.5 into 1. So 2.5, 3.5 and 1. Okay. So just multiply this, you will get the final 2.5 minus 3.5 plus 2, 2.5 minus 7 plus 5 minus 2.5 plus 7 minus 4. After that, I'm writing it here. The final point you will get 1, 0.5 minus 0.5. Okay. So again, if you convert back into the 2D real space, so what we need to do? 1 divided by minus 0.5, 0.5 divided by minus 0.5. So here you will get minus 2 and minus 1. So given the same h above the and a point x prime, find out the original point x in I1 using h inverse. So the original point x using h inverse, you will get minus 2 minus 1. This one. Okay, this is the original point of I1. Point I1 using h inverse. Okay, okay. So I hope you have understand this question how to solve. Similar type of question already we have solved once. Okay, so have you got any doubt?
No, ma'am.
Okay, so moving to the next question. So now next question is in projective space, 2 points P1 and P2 are considered equivalent if they have the same magnitude, or option B, they lie on the same Euclidean line, or option C, they differ by a non-zero scalar multiple, or option D, they have the same third coordinate. Which option is correct? In the projective space, 2 points P1 and P2 are considered equivalent if. So as many questions on that we have solved and many times we have seen 2 points in P1 and P2 in the projective space differ by a non-zero scalar multiple. One question we have solved that P1, P2 is equal to lambda P1, that is line 1 L2 is equal to lambda L1, right? So they will differ by a non-zero scalar multiple. It is a non-zero scalar multiple. So in the projective space, 2 point P1 and P2 are considered equivalent if they differ by a non-zero scalar multiple. So option C is the correct answer for this question. Okay. Now moving to the next question. Next question is a 2D projective transformation is represented by a 3 cross 3 matrix H. Which of the following statement is always true for projective transformation? Option A. H preserves distances between points. H preserves collinearity of points. Or option C. H preserves angle between lines. Or H maps circles to circle. So which option is the correct? A 2D projective transformation is represented by 3 cross 3 matrix H. Already we have solved many questions, that is H is a 3 cross 3 matrix. Which of the following statement is always true for the projective transformation? So in the projective transformation that preserves collinearity but not distances or angles. Already we have seen. Circles may be transformed into conic in general, but it is in general. Okay, so correct option, that is H preserves collinearity of points, not distance and their angles between the lines. That does not preserve. That angle may vary and distance also that can be vary in the projective transformation, but always it preserves the collinearity of the points. Okay. Okay, so I hope you are getting. Now moving to the next question. The next and final question is, if two lines in projective space are represented by L1, that is ABC, and L2, KA, KB, and KC, then they are parallel, or option B, they intersect at infinity, or they are the same line, or none of the above. So already L1 is represented by ABC. Yeah, someone want to answer this question? Please answer. And L2 is KA, KB, and KC. If we take common case, so you will get again A, B, C. That means is L2. So L2 is equal to K into L1. And many times we have seen they are the same line with some scalar factor, the non-zero scalar factor. So they will represent the same line. Okay. So option C is the correct answer. They lines are the if they are same, they can scale by some non-zero scaling factor. Okay. So these two lines is related to by the same scaling factor. So these lines are the same line. Okay. So option C is the correct answer for this question. Okay. So now the questions have been completed. If you have any questions or doubt, you can ask. Okay. You have any questions or any doubt related to these questions? Okay. Or you want anything else to from my side to do anything? Okay. Yeah. Thank you everyone. Thank you for joining this session. You want any modification, any improvement from the questions, or is it okay for you? Anyone? Don't comment anything. Is it okay? The questions are okay. Are you able to solve this question, or is it similar to assignment problems? Are you able to solve these assignment questions? Okay. Yes, yes, it is. It will be shared on the recordings. It one option will be there, the live and interactive or live session. There one is a one recording. It is given. So there is a YouTube video of this session and a link of Drive where all the questions PDF you will be given. Okay. Okay. So if you don't have any doubt or any questions, so we can close this session. Okay. So now if you don't have any doubt or question, you can leave this session. Okay. Okay. Thank you everyone. Thank you for joining this session. Now I am closing this session. Okay. You don't have any doubt, so we can close the session. Okay. Thank you. Thank you for joining this session.